Hello, my name is Lindsey Jackson, and this is my research on how the loss of ciliary adenylyl cyclase 3, or ADCY3, leads to severe obesity in a mouse model. ADCY3 is a key effector protein in many GPCR pathways which are important for regulating feeding behaviors and is predominantly localized to neuronal primary cilia. Here, we show that a novel mutation of ADCY3 that results in the loss of the C-terminus of the protein leads to severe obesity in mice. Figure 1 shows the visualization of neuronal primary cilia through immunofluorescence staining for ADCY3. Figure 2 shows the glomerular layer of the olfactory bulb of wild-type and mutant mice. Here you can see that ADCY3 is no longer detectable within the neuronal primary cilia of mutant mice. Figure 3 shows the body weights of wild-type and mutant mice from 3 weeks through 21 weeks of age. As you can see, the body weights of the mutant mice are significantly increased compared to their wild-type littermates. We measured the locomotor activity of the mice during light and dark cycles of 4 hours each to account for their normal activity increase at night. In Figure 4, you can see that male and female mutant mice showed significantly less motor activity than their wild-type littermates during both cycles. The average volume of oxygen gas the mice consumed is a closely related measurement. Sure enough, we found that the mutant mice consumed significantly less oxygen than their wild-type littermates in both the light and the dark cycles. Figure 5 shows the average amount of food and drink consumed by the mice during the light and the dark cycles. Surprisingly, there was no significant difference in feeding or drinking behavior between the wild-type and mutant mice within the same cycle. Using a 2-bottle choice task, we measure the preference of the mice for sucrose over water, sucralose over water, and sucrose over sucralose. As you can see in Figure 6, there is no significant difference in the sucrose preference between the wild-type and mutant mice, suggesting that the loss of ciliary ADCY3 may not alter all reward signaling pathways in primary neuronal cilia. Figure 7 shows the expression of tyrosine hydroxylase, or TH, in the glomerular layer of the olfactory bulb of wild-type and mutant mice. This immunofluorescence staining can be used to identify dopaminergic neurons. Wild-type and mutant mice showed very similar expression for TH, further supporting the idea that some reward signaling pathways can still function after the loss of ADCY3 in neuronal primary cilia. The findings of this study offer some insight into the role of the ciliary localization of ADCY3 in circuits related to feeding and reward behaviors. Further investigations will include similar measurements before 6 weeks of age to provide further clarity on the causal relationship between obesity and lower activity levels. Please feel free to ask any questions you may have in the comment section.